Find the limit. The limit as r goes to infinity of e to the r divided by r plus 1 to the fourth. As r goes to infinity, e to the r is going to go to infinity. And r plus 1 will go to infinity, which means r plus 1 to the fourth will go to infinity. So we end up with an indeterminate form, infinity over infinity, which is one that we may try to apply L'Hopital's rule to. By L'Hopital's rule, we have the limit as r goes to infinity, the derivative of the numerator, which is still e to the r, divided by the derivative of the denominator, 4r plus 1 cubed, times 1 for the chain rule, right? The derivative of r plus 1 is simply 1. This also goes to infinity over infinity, so another indeterminate form. But notice now the power of our r plus 1 factor has decreased from 4 down to 3. So maybe we're getting somewhere. Let's do L'Hopital's rule again. The limit as r goes to infinity. The derivative of the numerator, the derivative of e to the r is e to the r, divided by the derivative of the denominator, 12r plus 1 squared, again times 1 for the chain rule. Same thing is going to happen, infinity over infinity. But yet again, the power of r plus 1 is decreased. So let's go again. So by L'Hopital's rule. So r goes to infinity. E to the r divided by 24 r plus 1 times 1. Oh, looky there, infinity over infinity. One more time, our r plus 1 should go away. So by L'Hopital's rule, we now have the limit as r goes to infinity. The derivative of the numerator is e to the r, divided by the derivative of the denominator is just 24. Well, now, e to the r is going to go to infinity. And if you divide that by 24, you're still going to infinity. So this tells us that our limit does not exist, and it does not exist because as r gets larger, the value of the function gets larger as well, unbounded.